Hello. Am I audible?
Yes.
Yes, sir.
Fine. So, very good evening to all of you. And today's session is about we are going to revise the content and concepts of week 3 and week 4. Okay. So we will be covering every concepts of week 3 and week 4 in today's session. Okay. So we will covering by the qualifier point of view, exam point of view. We are not will not go in that much depth because we have to cover the content of 2 weeks within this time. Okay. Meanwhile, is there any session from 8 onwards?
Yes, sir. We have a session
Sir,
for maths
Yes,
too.
sir.
Maths 2 or Maths 1?
No, sir, maths too.
Max one.
It should be Maths 1, right? That will be. Okay, so we'll try to cover. So we will not go in that depth for every topic. So I will cover the I mean, we'll revise the concept as the exam wanted. Okay.
Yes,
For
sir. But sir, just please try to complete it by 8 so that we can join the other class as well.
yeah, that's why I
Thank you.
asked. Yeah, accordingly we'll see. Okay. So if you want the things in more depth and all, so there are discussion forum, discourse and all. Or as I can remember, we have discussed the things in depth. I mean, derivation and all in week 3 open session. You can no go through it again. Okay. Okay, so okay, let's start. Let me share my screen. Can you see my screen? Everyone?
Yes, sir.
Yes, sir.
Fine, great. Okay, so till week through, as there was session, right? Revision session. You have seen that categorical. I mean, all the things about categorical data, right? Visual representation of categorical data. Center and tendency means mean, sorry, not mean, median and mode for categorical data and all. Okay, all those things. In week 3, we will be moving to for the numerical data. Okay, basically. I mean, if you see, so we have, if you see the about variable and all, so we have two kind of variable initially. First one is categorical. Okay, another one is the numerical. Okay, so you know what is the categorical, the data on which we can't perform any meaningful mathematical operation, right? Numerical means we can perform meaningful mathematical operation. In numerical, we have two things. First one is discrete, another one is continuous. And what is the discrete? Discrete is something which where count is involved, right? I can count. For example, number of students who joined the live session, or number of people in a room, something like that. In continuous, what is there? Measurement is there. Means we cannot count. We can't count, but we have to measure. Measure means, for example, you say height, right? So height is something you cannot count, right? You have to measure in, let's say, feet, in centimeter and all, right? Similarly, weight of person, right? And if you draw a real line, right? So in discrete case, it will take distinct value on real number line. It cannot take let's say it cannot take any value, let's say, between these two number. While in continuous, if you plot a real number line, right? If you draw a real number, right, it can take any value between the between an inter. Okay? So that's the major difference between discrete and continuous. Okay. So there is something next. See, regarding categorical data, you have seen pie chart, Pareto chart, bar chart, and all. To plot, there is one something called histogram. Okay. So histogram is something which is very popular graphical summary for continuous data. Why? Because in histogram we are making continuous bar. Okay, and there are we are making class bins. Let's say suppose this is the first bar, second bar, some third bar, fourth bar. Okay, something like that. So this will be, suppose this is 0, this is 10. Next one is it will start from 11 to 20, so something like that will be there. Okay, Means for each beans, okay, there will be two limit. One is lower limit and another one is upper limit. Okay. So how we are denoting that? So basically we are writing class things as like this. So this is the lower limit of the class and this is the upper limit of the class. Okay. Okay. I mean, are you getting the point, right? Please do let me know at any step you are not getting. Okay.
Yes, sir.
Yeah. Okay. This is the lower limit. A is called lower limit. B is called the upper limit. And how we can find the class width? Suppose there is another class called C comma D. So class width is nothing but it's a difference of the no between the lower limit. If I will say what is the class width? So class width is, let me write. So class width is nothing but C minus A. For example, suppose there is class like this. Okay. Next one is 10 to, let's say, 20. So what is the class width? So lower difference of lower limits between these two classes. So class width will be 10 minus 0, which is 10. Okay, something. Is that all right? And so we are plotting the beans on x-axis. This is called x-axis, and this one is called the y-axis. On y-axis, there will be some numbers. Let's say in 0 to. If you see the let's see the scenario of marks of student. Suppose you are going to make beans of marks. So suppose this is on x-axis we are plotting marks, and in y-axis let's say number of students. So you might be interested how many students are in the beans 0 to 10, 10 to 11 to 20, something like that. So if you come to next concept, that is called stem and leaf plot. Okay. So this is the very good thing. Okay. Basically, stem and leaf plot. So by the nomenclature, if you see, so there will be two parts of that graph. Okay. It's basically diagram. One called stem, another called the leaf. Okay. In that, I mean, we are we are separating the values in two terms. I mean, basically, we are splitting. What do you mean by splitting? Let's say I'm going to make the stem and leaf diagram for some numbers. So let's say I'm going to make like this. Let's say it's a 2, 3, 4, 6, and let me write it for 4, 3, 9. Then 5, 0, 1, 2, 6, 1, 8, 9. So if you see, suppose there will be key provided. What is the meaning of key? Like how we are going to interpret the observations from my diagram. Suppose key will be like this. Suppose I will say 2 give oblique 3 means 23. So that means what are the observations we have from this diagram? Can you tell me? It's a
23, 24, 26,
right 23, 24, 26.
43,
Okay,
49.
can I write 30?
No, sir.
We can't write. Okay. So 43, 49, right? 50, 51, 52, 61, 68, 69. So you can get the observations from this stem and leaf diagram. Suppose this stem and leaf diagram is given to you. If question is like what is the median of this data set? Can you tell me? Suppose these are the marks of some 11 students. Okay. So can you tell me the average marks of this? Yes or no?
Yes.
Correct. So what we have
Yes.
to do by the provided key, right? With the help of provided key, you have to see the observations and then you can simply approach your. I mean, you can simply apply your concept whether you to find the mean, whether you to find the median, whether to find the mode and all. Okay, is that all right so far?
Yes,
So
sir.
if you see,
Yes,
observe,
sir.
if a question is asked about what is the median and all, so there is no need to arrange the data in ascending order, right? Because this one advantage of this system and leaf plot is the observations are already in ascending order. Okay. Okay. Any doubt so far? Is this clear, right?
Yes, sir.
Yeah. So next is measures of central tendency. Okay. So what are the measures of central tendency? Basically, why we are moving to this? suppose this is the marks of some 11 students, right? So rather than saying marks of this and this students is 23, 24, 26, something like that. So if you want to summarize your data set or marks and all or something in a single number, so okay. So in that scenario, the measures of central tendency is helpful. Helps us.
Sir, can you repeat?
Okay, for example, suppose there is a class. Okay, in the class there are some 40 students. Okay, you want to get some idea regarding marks of those students, right? Regarding performance of those students. So suppose rather than observing the marks of individual students, it's good. Suppose I'm saying average marks of the class is 80. Okay, then you will be having some idea, right? The students are good in that class, right? The performance of the students is good, correct? If average marks is 80, I mean something like that. Means if you want to explain your data set in a single number, not in whole observations and all. Got it?
Yes, sir.
Okay, fine. So there are some measures of central tendency. First one is called the mean. So we are aware about this. What is the mean? Basically, suppose I have observation, let's say x1, x2 up to let's say xn. Okay, a number of observation. Then mean is normally we are denoting with x bar. So it's nothing but addition of all observations. Okay, divide by number of observations. Okay, for example, I have observation 1, 2, 3, 4, and 5. Then mean of this observation will be 5 plus 4 plus 3 plus 2 plus 1 divided by 5, which is nothing but okay. So this is something mean we are doing. If let's say there is one formula, suppose each observation is repeating with some frequency. Okay, means suppose this is the observation. Suppose I'm saying 1 1 2 3 3 4 4 5. Okay, so how will you calculate the mean? So there is one approach, the very similar approach. Let's say I can do addition of all the observations, right? Correct. Then divide by number of observations. Correct. For example, suppose this is a very you have large data set, right? So rather than adding all the observations, what you can do, you can simply do the same thing. Suppose xi means observations. What are the unique values? 1, 2, 3, 4, 5, right? And what is the frequency? I mean, how many times one is occurring? Two times. Two is occurring one times. Three is occurring two times. Four is occurring two times. Five is occurring one time. So if you see from here itself, how many observations we have? Three, three, six, two, eight, right? So if you see from here itself, so what I can I write? One into two plus two into one plus three into two plus four into two plus five or not? Can I write? Yes, no?
Yes.
So this is the observation. This is the frequency of that observation. This is the observation. This is frequency of that observation. So another formula of mean is nothing but summation of I equal to 1 to n means number of observation fi into xi divided by summation of fi means addition of all the frequency. Okay. So what you have to do? You have to do fi into xi. Then and what is the addition of all the frequency? If you add 2, 1, 3, 2, 5, 2, 7, 1, 8, right? If you count again, you will get the 8. So this is the same as count. Actually, summation of frequency is equal to n. N means number of observations. Okay. So I mean now is it clear? Somewhat idea is okay for everyone.
Yes.
Okay.
Yes,
Like
sir.
it's a
Sir.
very simple calculation, right? Regarding mean and all. Okay. Hello. So next one is median, right? Okay. So what does median do actually? So median of any data set, right? So it's nothing but it divides my data into two equal parts. Okay. Basically, it's a kind of 50% percentile. I mean, we'll go to percentile concept. So what we have to do in the while calculating the median, very first step is okay. Anyone can tell me what is the first step to calculate the median?
Order data.
Can
Ordered it.
arrange in ascending or
Correct.
descending.
We have to arrange the data in ascending order. Correct. Okay. What is the next step? I have to see number of observations, right? If this is even, correct? or this is odd. So if n is even, right? So what we have to do? So we have to see the average of, anybody can tell me?
n by 2 plus n by 2 plus 1.
Correct. We have to see the average of n by 2th observation and n by 2 plus 1th observation, right? Okay. Everyone is getting this concept, right? Or any doubt? I will take one example, okay? Don't worry. And when n is odd,
So then we take n plus 1 by 2 with
correct. So median is nothing but, then median will be n by 1, sorry, n plus 1 by 2th observation. Okay? So what is meaning of this? Suppose I of data, let's say 1, 3, 2, 5, okay, 4. Then what we have to do? We have to, first of all, we have to arrange in ascending order, right? Then it will be 1, 2, 3, 4, and 5.
3.
And what is the n here? How many observations we have? 5,
5.
correct? If you see 5 is the odd number. So what will the median? Median will be 5 plus 1 by 2th observation. That means 6 by 2th. That means third observation. So if you see third observation in the ascending order is 3, not in this one, not in order, in the ascending order one. So your median will be 3, right? Is this clear?
Yes.
Correct. Suppose one more observation is there, let's say 6. Okay, for example, 6 is there. Then if you see n is 6, right? Here, how many observations we have? We have 6 observations. Then median will be n by 2th and n by 2 plus 1th. That means 6 by 2th, average of these two, correct? And 6 by 2 plus 1th observation, right? So we have to take the average of third and fourth observation. What is that? So third observation is 3, fourth is 4. So 3 plus 4 divided by 2, which is 3.5. Okay. Is this clear?
Yes.
Okay. Or
Yes,
simply you
sir.
can do, suppose you have less number of observation, then suppose we have data set 1, 2, 3, 4, 5. Just find the middle one. So if you see, this is the middle one, right? If it's odd, correct? Correct? Yes or no? If
Yes.
you have even, correct? Let's say even. So let's, if you see, so these two are the middle one, correct? These two are
Yes,
the
sir.
middle one. Just take the simply average of this. If you have very less number of, and I mean, you are able to simply separate the equal number of observations from the, I mean, that should be the 50 at the position of 50th person. Okay, correct?
Yes.
Yeah. Next one is mod. Okay, so the pace is okay for everyone because I'm going very little bit quickly because we have to just we are just revising the concept. Okay, do let me know if
Sir,
that is
sir, I have one basic question, sir. I'm
yeah.
sorry if my question is wrong. In the median, actually, like, why can't I take the average of all the n observations? Will
No,
it
then it
not
will
be
be
okay?
if you take the average, then it's a simply you are taking going to take the average, right? Mean. It's a mean of it. It's not a median.
Oh, okay. Okay.
Okay.
Got it.
If
Got
you're
it. Got
taking
it.
basically what median tells you, basically
Ah,
it divides the data in two equal parts, right? Suppose you
okay.
have data set like this. Okay, this is the whole
Okay.
data set. Then
Okay.
median will be at this step. Means it
Oh,
divides the data in two equal parts. That means 50% observation will be this, 50% observation will be this. Okay.
okay. Okay.
Suppose median of a class is let's say x. Okay.
Okay.
That means 50% are 50% of them are below this x and 50% are of above this.
Above the
Okay.
text. Okay, sir.
That is
Got
the
it.
objective behind median. Is that clear?
Okay, sir.
Okay.
Done, sir. Thank you.
And mod, it's a very simple thing. Mod of any data set is just nothing but we have to see the observation which occurs most frequently, right? Right? That in just we have to count the which observation has occurred more frequently. Let's say I have the data set 1, 2, 2, 3, 4, 5. Okay. Then what will the mod for this data set?
2.
2, right? Suppose you have 3. Then what will be mod for this data set? 2 and 3.
2
Now
and
this
3.
data will be bimodal. Bimodal means there are two modes, right? If there are
Sir,
more than two modes, that means that it will call the multi-mode. Okay.
sir, excuse me, sir.
Yeah.
Similarly, the outliers, will they affect the mode, sir? Outliers, if they are there
Yeah, it's a least effective
affected,
to
but But if we take the same number of outliers as the mode, then the mode will be changed, or the
It will
what?
change, right? See, okay,
Outliers
okay.
will.
I will come to that. Okay. Suppose I have observations 1, 2, 3, 4, and 5. Okay, okay. Then let's say I have some more of this like this. Okay. And what is the tell me what is the mean of this? It will be 2, 2, 4, 4, 3, 7, 4, 11, 5, 16, right? 16 divided by 5. So 3 point something, correct? 3.2. Yes or no?
Yes.
And
Yes, sir.
what will the median?
3,
Median will be 3.
3,
What is the mod?
2.
2.
Correct. Suppose I'm going to add a one extreme values, right? Let's say instead of 5, you have some 500. Okay, for example. Okay, I'm just taking some dummy value. Then what will the mean? Okay, mean will be 2 to 4, 3, 7, 4, 11, 500, 11 divided by 5. Can anyone tell me the value? 511 by 5. So it will be 102.2, correct? What is the median here? Is still 3, correct? What is the mod here?
2.
2.
Correct? So you can see the mean is more effective by the extreme values, right? There is a significant change in the mean value. Yes or
Yes,
no?
sir.
And there is I mean, here median and mod are same, but we can't say this is not effective by the extreme value at all. Median and mean are least effective by the outliers actually. Okay, you can't say it doesn't affect at all, but it's the least effective. It will depend on the scenario, right? I mean, how many it will depend on the number of extreme values as well. But mean is more effective by the extreme values in my data. Okay. So there is one more concept by adding a constant, multiplying by a constant and all. Okay. So if you see, suppose I have observations 1, 2, 3, 4, and 5. Correct. Then tell me what will the mean? Is the 3 correct? Let's say it's 2 to itself, 3.2 itself, right? And what is the median? Median was 3, and what was the mod? Mod was also 2, correct?
2. Yes.
Now, if I want to add a constant, let's say 3 or let's say 7 to all these observations, okay, then what will be the new data set? First of all, it will be 9, 9, 10, 11, and 12, correct? What will the mean of this new data set?
10 plus
Well,
2.
we'll just add
10.2.
7 to the old mean. That's 10.1.
Correct. Basically, if you add 9 plus 9 plus 10 plus 11 plus 12 divide by 5, then you will get 10.2. Okay. And what is the median here? If you see, median is 10
10.
and mod is 9.
9.
So this
9.
10.2 is same as 3.2 plus 7. This is same as 3 plus 7, and this is same as 2 plus 7. So if you see, what is this? This is old mean, right? This is the median of old data set. This is the mod of old data set. And what is this 7? This 7 is nothing but that constant value, correct?
Yes. Add a constant.
Correct. So I can see, suppose I have observations x1, x2 up to xn, and I'm going to add a constant c to all these observations. Then my new data set will be yi equal to xi plus c, correct?
Yes.
If this is the case, then new mean will be means mean of the new data set. It will be same as mean of the old data set plus that constant,
Same.
correct? Same. Median of new data set will be median of old data set plus that constant,
Constant.
and similarly median of mod of new data set will be mod of old data set plus that constant, right?
Constant.
Is that clear to everyone?
Yes.
Similarly, if I want to multiply by a constant, right? If I want to multiply by a constant c, Then my new observation, why I means after multiplying or adding that constant. So it will be xi times c, right? Then the procedure will be same, means your mean of new data set will be old mean into that constant. Same new median will be old median into that constant, and same
Constant.
for the mod itself, right? So is this clear, or you want to do with me example by example? This
Clear, sir.
multiplying is it clear, right, for everyone?
Clear, sir.
Yes, sir.
Now, so far we have seen these measures of center tendency and all. So let's. Oh, there are some background noise. Please mute yourself if you don't have any doubt. Okay, you can unmute. So next one is called some measures of dispersion. Means we want to see what is the variability in my data set, right? How much variability is there in my data set? What is the scatteredness and all, right? Okay. So first measure called the range. Okay. Because the range is by the nomenclature, range is just nothing but maximum minus minimum. Okay. So range of any data, suppose I have 1, 2, 3, 4, and 5. Then what is the range of this data set? It's a 4. Because maximum is 5, minimum is 1. Correct? Yes or no? Okay,
Yes,
so
sir.
can you tell me range is very sensitive to outliers? Because suppose instead of 5, I have 500, their range will change significantly, right? Yes or no? Because maximum will become 500, minimum is still 1. It's a 499. Yes or no? So range is very sensitive to outliers actually. Okay, because it consider only maximum value and minimum value of that data set. Yes or no?
Yes, sir.
Mhm. Now, so next one is variance. So anyone can tell me why we are moving to the variance? You have seen the lectures video, we have seen the live. Anyone can tell me what's the use of variance?
The deviation from centric value.
That's the variance does, but what's the need of variance? Yeah, feel free to say whatever.
Sir, to
Show the
see how the
dispersion of
number
the data.
relate to each other.
Sorry, can you repeat?
Sir, to know how number relate to each other within a data or not.
Okay, fine. Let me
Sir,
explain.
the
Yeah, go ahead.
data which is given is how
Hmm.
they vary from each other.
Yeah, varying from the mean itself. That is it. Okay, let me tell you the objective behind the variance. Okay, suppose there is two college X and college Y. So suppose you are an analyst and you want to know the some let's say average annual package of that college. Okay, college X and college Y. Okay, let's say 30, 30, 30, 30. So these are packages of some five random students and in lakhs. Okay, then what is the average of this thing? It's a 30 lakhs, right? Correct. And for in college Y, it's again 30 lakhs. Okay. If I will say the average annual package in college X and college Y is same, which is 30 lakhs, 30 lakhs. So in reality, performance are correct. Performance are same, or is
No.
there any variability?
No,
No,
sir.
sir.
Performance varying.
Varying, right? If you see 10, 20, 30, 40, 50, even 30. So if you see here, there is no variations, right? Correct. So you will
Yes, sir.
prefer, okay. Suppose you are an analyst, which college you will prefer? College Y or college X?
Sir, why?
Y?
Yes.
Yeah, you will select Y, college Y, but Y region.
Sir, it's less debating from its mean.
Correct. So there is, for this example, there is zero variance, right? Means less variability, right? Yes or no?
Yes.
So that comes up. That's why this variance came into the picture actually, because average will tell you the central idea, but it will not tell you the what is the scatteredness, I mean variability in your data set is there. Okay. So there is two kind of variance. First one is called the population variance. Okay, we are not going to the, I mean, the derivation behind the formula. So population variance is denoted by sigma square, which is 1 upon n summation I is equal to 1 to n xi minus x bar square. Okay, I'm hoping you are aware how to calculate this variance. Yes or no? Because this xi is nothing but observation. This x bar is nothing but mean. Okay. And
Yes,
another
sir.
one is sample variance. So notation for sample variance is s square. So the difference in the formula is in the denominator, it's a n minus 1. In case of population, it's a n. Okay. So what you have to do, you have to clear with these things. Okay. I mean, you have to keep in the mind the difference for this n and n minus 1. And because suppose I have observations 1, 2, 3, 4, and 5. So this is the xi, right? Then you have to find the x bar. X bar is the 3, right? So what you have to do? Xi minus x bar. Yes or no? So xi minus x bar is 1 minus 3. That is minus 2, minus 1, 0, 1, 2. What is the next? You have to do xi minus x bar square. That will be 4, 1, 0, 1, 4. So if you see what is the after that, you have to add all this, right? So it will be 4, 4, 8 to 10, correct? So if I will ask sample variance, then what you have to do? 1 upon, tell me,
4.
4, right? Because it's a n minus 1. So you have 5 observation, it will be 5 minus 4 into 10. And population variance, it will be 1 upon 5 into 10. So this is something why we are using n in the denominator and in n minus 1. So we are not going into the that much depth. These all things will no, we are going to study in stage 2 course the next semester. Okay. So as of now, you can keep in your mind just formula itself. Okay. So anyone can tell me, suppose I want to add a constant c, then what will be the new variance? I mean variance of new data set,
Sir, it will remain the same.
Same.
Sir,
Same.
yeah, it will remain the same.
the same, right? Have you
Yeah.
seen the derivation behind it? We have done in the week 3 open session, right?
Yes, sir.
There will not be any effect by adding a constant. If I will multiply by a constant, right?
Yes, sir.
Then new
Square
variance
of
will be
that
It will be
constant.
c square times.
c square. C square means constant into
Yeah.
variance of,
Old variance.
okay, old previous data set, right? So next part is called standard deviation. Okay.
Sir, I have
Yes.
a doubt.
Yeah. Please go ahead.
Sir, if we multiply the old variance with a constant plus we add one constant, then what will happen?
No. You have to do only one procedure. Either you have to multiply or either you have to add. I mean, simply, okay, okay.
Step by step.
You mean, suppose X is the one data set, right? So you mean you want to do 2x plus 3 like this?
Yes, sir.
Yeah, then you have to apply this procedure, right? If it's a 2x plus 3, okay, tell me, suppose this is the y, then variance of y will be what? Variance of 2x plus 3, right? What does this mean? See, here it means you are multiplying a constant, right? Yes or no?
Yes,
Yes,
sir.
So it will be 4 times
4 times
variance of,
variance of f.
yes or no?
yes, sir.
Yes, sir. Plus 3 times 3.
No. There will not be any effect of 3 because here we are adding,
Yes, sir.
fine. So there will not be any effect by adding a constant. Okay. So basically you have to, there is need to understand this point. Okay.
Yes.
So next one is standard deviation. Any one of you can tell what is that? Whatever the things
Simply
you
a square
got
root of
in,
variation.
Under
sorry.
root variance.
Sir, by using variation, we can find the measure of dispersion, but units are not preserved. So we have to Calculate the standard deviation
Yeah,
so
correct,
that
correct,
units won't change.
correct. Great. So basically, standard deviation is defined the square root of the variance. Okay. So what's the need of this? Because suppose you got the variance as 4, then what's the need of taking the square root of 4? So thing is that suppose it's the case of unit. Okay. Means suppose your x is age. Okay. Age, it denoting age. And you have calculated the variance. Suppose then variance will be, suppose it's let's say 16, then it will be 16 year square, right? Variance will come out to in year square or not, because we are doing xi minus x bar square, right? Sorry.
Yes, sir.
Yes or no?
Yes, sir.
So to compare the data set, if you will take the square root of 16 year square, then you will get the 4 year, right? Okay. So your
So right.
original data will be in, I mean, the
Year.
unit of this standard deviation will be same as in the unit of the original data set. Okay. So it's a square root of variance. So what will be the sample standard deviation? So it will be square root of 1 upon n minus 1 summation I to n xi minus x bar square, right? And population standard deviation, it will be square root of 1 by n summation of xi minus x bar square. Okay. Is that all right so far?
Yes, sir.
Yes, sir.
The same thing here for adding a constant. Then what will be the new standard deviation? It will be same as standard deviation of old, right? Old data set, correct?
Yes, sir.
Correct. And in case of here variance, I mean, when you are going to multiply by a constant, then it will be new standard deviation. Since we are taking square root, then it will be C, right? C times standard deviation of old data set. Okay. Is this clear? Any doubt? Yes, no,
No doubts.
no doubt.
Sir, one more time.
Yeah, go ahead. Yes, someone is saying something.
Standard deviation. Repeat
Yeah.
one time.
Okay, this property part.
Yes, sir.
Okay. So what we have seen, if we are going to add a constant, right, to all the observations of a data set, then there will be a new data set, right? I mean, data set of new observations, correct? Because suppose you have data set 2, 3, 2, 2, 2, 2, 2, correct? Then you want to add 3, then your data set will be 5, 5, 5, 5, right? Then the newest variance, I mean, variance of new data set will be same as variance of old data set. Okay. Everyone is getting the algorithm behind it, because we have done the derivation in week 3 open session, right? So you can rewatch, or should I do?
No, sir, it's fine, sir.
It's fine, right?
No.
Then, okay, great. If I want to multiply by a constant, right? Multiply by a constant C, then the variance of new data set will be C square, means square of that constant into old variance. Okay. Then what is the standard deviation? Standard deviation nothing but square root of the variance, right? If you apply the same thing here, if you find the standard deviation, then here it will be same, right? New standard deviation will be same as standard deviation of old data set, yes or no?
Yes,
Yes,
sir.
sir.
Correct. On the left, right, you have to just take the square root, right? In this case, if you take square root, then new standard deviation will be C times standard deviation of old data set, correct? Because you have to
Yes, sir.
take the square root, right? That is
Yes,
the
sir.
thing. Okay? Is this clear now?
Yes, sir. Okay.
Yeah, correct.
Sir, I have
Sir,
one
I have a
question.
doubt in
Yeah, go ahead.
sir, what's a unit of standard deviation?
For
What a unit of standard deviation?
yeah, so your doubt in unit of standard deviation.
Yes, sir.
Okay, basically standard deviation we are calculating to get the things in unit in which our original data set is there. Okay. Suppose your data set, let's say there are data of age, okay, then your variance will
Yes, sir.
be something, just assume it's coming out to be 16 year square, right? But your original data set in year, correct? You have calculated
Yes, sir.
your variability year square. If you will take square root of these two, right, then you will get 4 times year or not. So your standard deviation, basically now you have calculated your variability in the same unit as the in which your data set is there, original data set is. Is this clear?
Clear, sir.
Okay, fine. Okay. So
Sir, I
concept.
have a practical question. Like, like a data set is given, like, why do I use a standard deviation, or what is the significance it gives me the information about the data?
Yeah, that's why, so to get the things in the same unit, right?
No. What
Huh.
does the standard deviation tell me? That is my question. See, I have x1, x2, let us assume up to x10. Okay.
Okay.
So there is a standard deviation, some number is coming. So what does it tell me about that x1 to x10? Does it signify anything, or I don't know, like practically I'm asking.
Okay. Tell me what is the practical application of variance?
To understand, whether the data is similar or there is a huge variation or like outliers or something like that. Sir.
Correct?
Yeah.
Okay.
There is a
Suppose,
pattern.
okay, the main use of this standard deviation is the same, similar, very same as the variance itself. The only difference is we are taking the square root of variance. Why? To get the things in the same unit.
Same denomination. Okay. Same
Got it?
metrics. Okay.
Same
Okay,
matrix.
sir.
Because suppose I have data set of age, right?
Yeah.
Okay. Then your original data set will be in year. Correct?
Yes.
Correct?
Yes.
Okay. Tell me. Then how will you calculate the variance? Let's say I'm going to calculate the population variance for let's say sample variance. Okay. It will be 1 upon n minus 1 summation xi minus x bar whole square, right?
Yes.
Then let's just assume it's coming out to be 16 year square, right?
Yes.
And what is the sample standard deviation? Nothing but square root of this thing. Correct?
Yes, sir. Yes, sir.
Here you are going to explain in year square, but if you take the square root of this thing, you will get 4
becomes 4
year.
years. Okay, sir.
Now this is the unit is the same. Now it will
Yeah.
be easy to explain or interpret the results in the same unit, right?
Okay. Okay,
Got
sir.
it?
Got it.
Right?
Thank
Yeah.
you, sir.
Yeah. So next concept is percentile. So by the nomenclature, what is the
Sir, I had
percentile?
a doubt in one of the PYQs regarding the population variance. Can I ask that?
Okay, what is that? I don't have any PYQ right now, actually.
No, sir, actually, I have the question in front of me. It's like two teachers are assigned to check the mathematics papers attempted by the students of class 10th. The mean and population variance of marks is given. Like for the 20 papers checked by teacher A, the mean is 50 and the population variance is 16. And similarly for teacher B, for the 30 papers, the mean is 60 and population variance is 25. But sir, what would be the combined population variance
Okay,
of
so
the
first of
entire
all,
set?
just find the a mean of combined. You can find the combined mean, right?
Yes, sir, I've done that.
Okay, so there is a expansion of formula, right? If you 1 upon n summation of xi minus x bar square, right? If you'll expand this formula, what you will get? Tell me. 1 upon n summation of xi square minus x bar square, right?
Yes, sir.
So from where you can find the mean, correct? Yes or no? See, you are saying some 30 papers, some 20 papers, right?
Yes, sir.
So for this 30 paper and 20 papers, first of all, you can find this one or not?
Yes, sir, we can. But sir, I didn't get. How did you expand the formula?
I
It's like
think, okay, then
this.
you have missed the, I'm sure you have missed the week 3 open session. We have done all the derivation. Okay, let me do the things little bit quickly. See, we are not going in the derivation part because we have to cover the things in the time because you guys have this another session from 8 onwards. Okay, so let me do the little bit fast. Okay, so this is a minus b whole square.
Yes,
I
sir.
can do this one. Yes or no?
Yes, sir.
Correct. So 1 upon n, summation I equal to 1 to n. If you take summation inside the bracket, it is summation of xi square. Yes or no?
Yes, sir.
Correct? I can do this one because I can take summation to the xi, right? Now we know what is the x bar. X bar is 1 upon n summation of xi, right?
Yes, sir.
Then can I write n times of x bar equal to summation of xi? So instead of summation of xi, can I replace this as n times of x bar or not?
Yes, sir, we can.
We can, right? So this is summation I is equal to 1 to n xi square. This will be n times of x bar square because x bar is constant value. We are adding x bar square some n times, right? I can write
Yes,
this
sir.
one,
Yes,
correct?
sir.
Minus 2 times of x bar into n times of x bar, right?
Yes, sir.
Because this thing summation of xi, we can replace it n times of x bar. So it will be summation of xi square plus n times of x bar square minus 2n times of x bar square, right? So this minus this will be minus n times of x bar square. Yes or no?
Yes, sir.
Correct. Now you can take n as inside, so it will be 1 upon a summation xi square, and this will get cancelled out. You will get x bar square. Now from here you can find the AC. To find the combined mean, first of all you have to find the summation of xi for
Yes,
some
sir. Yes,
30,
sir.
30
Combined
paper,
mean,
right?
I got it.
Then for 30 xi, right? Similarly, try to find the square. Okay, clear?
Yes, sir.
Sir, I have
So
also a doubt.
yeah,
Sir, a standard deviation is affected by outliers.
yeah, it's affected by outliers because in a standard deviation we are going to consider all the observations, right? If
Yes,
instead of 5, suppose 500 is there, then it will be affected. Okay.
yes. Thank you.
So let's
Answer
move to the
variance
next.
is also affected
Can
by
you
Yeah,
can you show the
see
previous page? I'll take a picture, sir, please.
this one.
Yeah.
Took you taken.
Okay, sir. Done. Next page.
Done.
Done. Thank you.
Sir, just a second. In that sigma square, sir, that is the xi square. That's the summation, or is it the summation of xi whole squared?
Okay, tell me what is this?
Ah, okay, sir. Got it. Got it.
Got
It's
it?
the square
Yeah.
of the
Square
individual
addition
elements.
of squares of the objects.
Okay, sir. Okay.
Yeah. So let's move to the next part, which is the called percentile. In percentile, what we are doing, let me give you the example. I will give you example. By the example, it will be clear to you. So it means, suppose I'm saying 25 percentile, for example. So what is the meaning of 25 percentile? It means 25% of the data are, 25% of the data are below this, and remaining 75% are above this. Okay. Suppose I'm saying 30th percentile, for example. This means 30% of the data will be below this, and remaining 70% of the data will be above this. Are you getting some sort of idea?
Yes.
Okay.
Yes, sir.
Have any one of you have given the JE exam and all? Have you heard about this JE, right? Hopefully you have, some
Yes,
of
sir.
you have
Yes,
given
sir. Yes, sir.
JE and all. You hope you have been heard about this GRE and all. So in JE, suppose someone got 90th percentile, right? So what does this mean, 90th percentile?
0.98%.
See, 90th percentile means 90% of the students are below this, and remaining 10% of the data of the students are above this, right? Suppose there is a student, let's say Aman, okay. So Aman got 90th percentile in JEE exam. That means his marks is, 90% of the students are below his marks, and 10% of the students are above this. Okay, that is the meaning of percentile. So is this clear? Some rough idea? Okay.
Yes, sir.
Okay.
Yes, sir.
How we can compute the
No, sir,
percentage?
only below or above, right? Like not equal to, no, in both directions.
Actually it's a something like that. You can interpret if you are taking 90% below, that means then you have to take the greater or equal to 10%, like this. Are you
Greater or
getting?
equal to also. Okay.
Yeah. Okay. So how to compute the percentile first of all? So first of all, what you have to do, anyone can tell me, those who have done?
Sir, first of all, you have to arrange it in ascending order, the
Correct,
data
correct.
set.
So many people make mistake in during the examination. I mean, they are doing the calculation and all correct, but they forget to arrange the data in ascending order. So keep in mind, you have to arrange the data in ascending order. Okay. And second one is, just see the N and P. N P means N is the number of the observation, P means percentage, means let's say 25 percentile. So you have to take P as a 25%. So second step is calculate the value of N into P. See, this calculation, the value of this NP can be integer, right? Or cannot be integer, right? It can be in decimal, right? Not an integer, yes or no?
Yes, sir.
Okay. If it's not in integer, right? Then what will be the procedure? We have to see, we have to determine basically the smallest observation. Okay.
Greater than
Smallest,
NP.
basically smallest integer you can see greater than NP. Okay. I will tell you if you are not getting this. If what is the and the value at that position will be, I mean value at that position, this smallest integer position will be our required that percentage. If NP is in integer, then we have to take the average of, okay, average of the values at the position. Which positions? At the NPth and NP plus 1. Okay. I will tell you the meaning of this. I mean, what is the things? Okay. Suppose I have data sets some 11, 13, 12, 15, and 14. For example, I have this data set. Then what is the first step? I have to arrange in ascending order, right? Then it will be 11, 12, 13, 14, and 15. Yes or no? Then we have to see N as, let's say, what is the N? N is 5, right? 1, 2, 3, 4, and 5. Suppose question is calculate the 25th percentile. Then P will be 25%, that means 0.25. Yes or no? Next
Yes,
step is calculating N into P. Then it will be 5 into 0.25. That means what? How much it will be? 5 into 0.25. Anyone? It's a simple calculation.
So 1.25.
1.2. Right. So if you see, this is in this value of NP is not in an integer. I mean, it's not an it's in decimal. Then we have to take the next smallest integer greater than this. What is the meaning of smallest integer? Because greater than 1.25, it can be 2, 3, 4, 5, anything, right? So greater than this, we have to take the smallest. Then what is the smallest one? That is 2. See, after 1.25, the smallest integer is 2, right?
Sir.
Yes, no, any doubt?
Yes, sir. Yes, sir.
Correct?
Yeah.
So that means we have to see the second observation. So what is the second observation? This is 12. Correct? So 12 is the 25th percentile of this data set. Is this clear? Yes, no?
Yes, sir.
Yes,
But
sir.
Yes, sir.
but if
Yes, sir.
if the number of observations would have been even, then
I will come to that one. Don't worry.
Can
It's
you
not
explain
about
this?
even. It is not about even odd. It's only about N into P. Okay?
Okay,
Okay.
got it.
Suppose I want to calculate the 70th percentile. N is 5 here, right? Correct? P will be 0.7. Yes or no?
yes,
Yes,
sir.
sir.
Then what will be the value of NP? 5 into point, correct? So it's a 3.5. So what is the smallest integer after 3.5?
4.
It's a 4. So
4.
fourth observation will be 70th percentile. So what is the fourth observation? It's a 14.
14.
So in the ascending order observation, we have to see the things, right? So is this
Sir, I
clear,
didn't
right?
get the last. How did that fourth observation came?
What is this 3.5? It's in decimal point, right?
Yes.
If value of NP is in decimal point, then we have to take the next smallest integer,
Okay.
which is greater than this. Okay. So after 3.5, it will be 4, right?
Yes.
So 4 means we have to take the fourth observation in the ascending order data set, right? So
Okay,
this
sir.
is 14, correct?
Sir, if it's
Sir,
not in decimal, then we will take the exact point. Suppose it is 3. Obviously, it won't come. Then,
Did you listen this one?
yes, sir.
So what is this? We have to take the average of that position, NPth and NP plus 1. I will come to that point. Don't worry. Okay.
Okay, 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 sir.
Okay. So suppose
if the observations are less like 5 only here, so by looking at the observations, can't we say that
see,
this
you
is
can do,
70-50?
we are not denying, you can do anything, right? But thing is that I'm just telling you the procedure with by taking the less number of objects. Okay. So for example here n is 6, right? Okay. Suppose I ask calculate the 30th percentile, then p will be 0.3, correct? Yes, no? So
Yes,
what
sir.
is the value of NP? 6 into 0.3, that is 1.
1.8.
So this is in decimal, right? If you see, then what we have to do? We have to take the next smallest digit, which is 2. So second
2.
observation we have to take. So second observation is 12, right? So 30th percentile of this data set will be 12. Okay. So someone asked for even observation. So this is the even observation. So here we there is no need to worry about number of even or odd. It's about calculating n into p. So let's come to that integer. Suppose I ask 50th percentile. Okay. So calculate the 50th percentile. P will be 0.5. Yes or no?
Yes.
So what is the value of NP? It's a 6 into 0.5, which is 3, right? Now it's in integer, right? So what we have to do, if it's integer, then we have discussed the method. We have to take the average of the observation which has position NPth and NP plus 1th. So here it's the third, right? So we have to take average of third and fourth observations. Okay, are you getting? So what is the third and fourth observation, which is 13 and 14? Yes or no? Okay. So 50th percentile will be here average of 13 plus 14 divided by 2. Is that all right?
Absolutely, sir. Correct. Thank you.
Correct?
Yes.
Got it? Okay. So here,
Yes, sir.
fine.
Sir, can you, sir,
Huh?
sorry to, can you just
Yeah.
explain once P and NP? I missed that in the beginning.
Okay, so P is something we have to take. Suppose a question is about to calculate the 70th percentile. So P will be 70 by 100. That means 0.7. Okay. N is number
Okay.
of observation. Okay. So here you can see N is let's say in this case N is 6, right? Correct. P
Okay,
is
so that will be given in the question itself, whatever the percentile we need to take.
yeah.
Right? Okay,
Otherwise, how you can it will mention which percentile you have to calculate. Okay.
got it, sir. Yeah, thank
So
you.
in the latest case, it will not be a value of the observation, right? In this
No.
one, 50th percentile will not be a value in the data set. It's a
Yeah,
fraction of
because it's coming if you see it's coming as a in integer, right? In
right.
case of integer, we are going to take the average of I mean average of the observation at the position NPth and NP plus 1.
Right. So and that value should not, even if it is not there in the data set, that's the result, right?
Yeah.
Okay.
So, sir, why we have not taken second and third average?
Second and third. It's coming out to be 3, right?
Yeah.
So value of NP is 3.
So average we have taken of third and fourth, right? In an even
I
observation.
think you did not listen to this procedure itself. What is this method? Method is simply saying we have to take the average of observation at NPth and NP plus 1th,
Oh,
not
got
NP
it, sir.
minus 1th,
Yes.
right? So we have
Sorry.
to
Yeah,
take,
yeah, got it.
yeah, if NP is 3, then it will be 4, right?
Yes,
Got
yes,
it?
got it.
Okay, yeah. So next concept is called the quartiles. So by the nomenclature, it's about quarter, right? 1 quarter. So what do you mean by the quartiles? Anyone?
So
Basically
quartiles are
it
basically
divides
Quarter
the
the
means
20.
quarter means 1/4 of the data set, right?
cell.
Correct?
Yes,
Yes,
sir.
sir. We have to
So
divide in 4 parts,
yeah,
equal
so
parts.
it divides the my data set in 4 equal parts. Here, just see. Yeah, I mean just treat each beans as the equal. Here I'm not able to do right now, but just treat. So what quartile does? It divides the my data set into 4 equal parts. That means suppose it will be each part will be 25%, 25%, 25%, right? So
Yes, sir.
basically this part calls the Q1. Q1 means first quartile. Okay, and this part called the Q2, which is the second quartile, and this part called the Q3, that means third quartile. Okay, so by this, can you tell me what Q1, how much Q1 covers? It means 25th percentile of my data set, right? Because before Q1, if you see before Q1, if this will be 25th percentile of data set, because 25% of the observations are less than this, and if you add all this, then it will be 75% of the observations are above this. Yes or no?
Yes, sir.
Yes, sir.
Correct. Similarly, Q2, it's a 50th percentile, right? Yes or no?
Yes, sir.
And this
Yes,
is
sir.
same as the median itself, if you observe carefully, right?
Yes, sir.
And
Yes, sir.
what about Q3? Q3 is nothing but 75th percentile, right? So if you
Yes.
see, why we are saying 75th percentile? Because if you see 75% of the observation, this 25 plus this 25 plus this 25. So 75% observations are less than this, and remaining 25% are above, right? Is that all right?
Yes.
Okay. So if you see, Q1 is 25 percentile, Q2 is 50th percentile, Q3 75th percentile. Can you calculate this Q1, Q2, and Q3? Right?
Yes, sir.
Because
Yes, sir.
we have to just approach the same procedure which we have done in the this case. Let's do this one. Okay, 11, 12, 13. Let's do little bit quickly. 11, 12, 13, 14, 15, and 16. So what is the n? N is 6. To calculate the Q1, it will be that means see. Suppose I ask first quartile. That means you have to calculate the 25th percentile, right? So what is the value of 6 into 25? Sorry, 0.25.
1.5.
1.5, right? So 1.5 means it's in decimal. We have to take the second observation, right? So Q1 will be how much? 12. So be
2.
careful, all observations are in ascending order. So very first step is you have to arrange the data in ascending order. Tell me 50th percentile. So n is 6, p will be 0.5, correct? So value of np will be 6 into 0.5, which is 3.
3.
It's in integer. That means we have to take the average of
Third and fourth.
third, fourth, and fourth.
Third and fourth.
That means Q2 will be how much? 13 plus 14 divided by. So you can see Q2 represents the 50th percentile, which is median. Means it divides the data in 2 equal parts. You can simply do, you can remove, I mean not remove, you can simply divide your data set. So in between 13 and 14 is there, you can simply take the average. Yes or no? What
Yes,
about
sir.
75th percentile? It will be P is equal to 0.75, right? So what is the value of 6 into 0.75?
4.5. 4.5.
So 6 into 0.75 is a 4.5. Now it's in decimal, right? So what we have to take? We have to take the next smallest digit, which is the 5. That means we have to take the fifth observation. So what is the fifth observation, which is the
15.
15, right? So Q3 is the 15, right? So can you calculate if there is any question you have been given the data set, you have been asked this quartiles, you can calculate, right?
Yes, sir.
Correct? Fine. So another
I have a
concept is,
question.
yeah.
Yeah, so if NP comes out to be the last value, like the last value in the data set, and it's even number of data sets, so in that case, we are only considering the NP and
Correct.
we're not considering NP plus one, right? Because
No,
there
no,
is,
it's if it's last, then you have to take only that. We can't go beyond that.
yeah, okay, got it.
So next one is called IQR. Full form of IQR is interquartile range. So interquartile range is defined as the nothing but Q3
Q3
minus
minus Q1.
Q1. I mean, suppose is there then there is a data set is given to you. You have been asked what is the interquartile range for that data set. Then what you have to do? You have to calculate Q3. You have to calculate the Q1. And you have to take the difference. So Q3 is 15 and Q1 for this data set is 12. So
12.
IQR is 3.
3.
Okay. So this IQR and all, it helps us to find out whether outliers are there in my data set or not. So there is a formula to see whether outliers is present in your data set or not. So what is that formula? So you have to check, you can simply say, check outlier is that observation. It should be less than Q1 minus 1.5 times of IQR. Means if there is any observation which is less than this quantity, right? You can calculate Q1 minus 1.5 times of IQR, then that will be considered as an outlier. And if there is an observation which is greater than Q3 plus 1.5 times of IQR, then that observation will be considered as the outlier. Okay. So this is the method to calculate. I mean, you can simply put the value of Q1. Let's say in this case, it's the 12 minus 1.5 times of
Sir,
3.
can you
So,
explain the outlier? 1 second.
okay. So outlier, you can simply find by this formula. Outlier is an observation. If there is any observation, right? Just calculate this quantity. If there is an observation which is less than this quantity, right? That will be considered as outlier. Okay. For example, Q1 for this data is 12, right? Minus 1.5 times of IQR. IQR is 3. So if you calculate this thing, correct? So how much you will get? So 12 minus 4.5, that is 7.5, right? So is there any observation which is less than 7.5 in this data set,
No, sir.
right? Just calculate this one. Q3 is 15, correct? Plus 1.5 times of 3. So what is this?
15.5.
15, I mean, it's, sorry, 4.5 plus 15, that means
19.
19.5. So is there any observation in your data set which is greater than this?
No.
No, right? Are you getting everyone?
Yes.
Okay. So that means there is no outlier in this. There is no outlier in this particular data. Got
Sir,
it?
order matters in outlier.
See, basically you can find the outlier by this formula. So to calculate these all things, right? See, anyway, if it's not there in order, right? You have to just see, is there any observation which is less than 7.5 or not? Suppose there is a observation less than, let's say, 2. Then you can say, is this is the outlier. Okay. You have to just see the procedure. Is this clear? Fine.
Yes.
Okay. Yeah. Okay, just give me 1 minute. I think I need to connect my laptop with the charger. I will be back in 1 minute. Okay.
Okay.
Sir, can you explain it again, please?
Yeah, hello. Am I audible?
Yes, sir.
Okay,
Sir,
fine.
please explain this outliers again.
Okay, so basically, outliers is nothing but how you can find the is there any outliers in your data set or not. So there is formula you can see in tutorial and thing. So that is something if outliers, so that means you have to check if there is any observation which is less than this quantity Q1 minus 1.5 times of IQR. If there is any observation which is less than this quantity, that will be considered as a outlier. For example, if you see, if you put the value Q1 was 12 minus 1.5 times 3, so we'll get 7.5. So in this observation, is there any observation which is less than 7.5? Yes, no?
No, sir.
No, right?
No, sir.
So there is no observation which is less than 7.5. Now, we have to check actually both conditions because it can be minimum, it can be maximum, right? Now, for this case, in the and you have to check is there any observation which is greater than this quantity Q3 plus 1.5 times IQR. So Q3 was 15 plus 1.5 times of IQR was 3. We got 19.5. So is there any observation which is greater than 19.5 in your data set? No?
No.
Right? That means there is no outliers in data set, right? Okay.
Yes, sir.
Now, so let's move to the week 4 content. Okay. So till week 3, we have discussed about one variable and all, right? In week 2 and week 1, we saw, we have seen both categorical variable and numerical variable and all. Now we will be moving to the part whether I can find the association between the variables or not. Is there any relation or not? Basically, okay, what do you mean by association? Anyone can tell me just a meaning of association. What do you mean by association?
Relation with previous data.
Togetherness.
Relation between
Relationship between two variables.
Relationship between two variables. Okay, basically. Means suppose I have information about one variable, so that should provide the information about another variable, right? Or I can say if I'm going to, if there is, I'm going to make a change in one variable, and then there will be change in another variable also, then I can say those two are associated. Otherwise, it is not associated. Yes or no?
Yes.
Correct?
yes, sir.
So to find the association, first we will see the association between two categorical variables. Okay. Association between two categorical variables means how we can check, is there any method to check the association between two categorical variables. So it's called contingency table. Inside that contingency table we can use two approach. First one called row relative frequency. Okay. Another one called the column relative frequency. Okay, you can use any one, it's not required, means you have to check both. You can use any method. You can use row relative frequency or column relative frequency in which you are comfortable, doesn't matter, but you have to check by the. Okay, first of all, can you tell me, okay, before going to, okay, so what contingency table is there? Says, I'm going to take the example which ma'am took. I think it's ownership of phone and gender, right? If I'm not wrong.
Yes, sir.
So I'm going to just explain by this example itself. Okay. Suppose I have two categorical variables. So ownership of a phone, right? Correct. And gender. So if you see here, gender is a categorical variable, right? Ownership of phone is also categorical variable, correct? Because in ownership of phone you can simply have yes, whether you can own or no, right? In gender you can have, let's say, female and male, right? Yes or no? You can
Yes, sir.
find the count but you can't perform the belief. Okay, suppose this is the two categorical variable, ownership of phone and gender. I'm interested to know whether ownership of a phone is associated with the gender or not. Okay. So suppose I'm going to with the count. I think anyone can tell me the values. I think it was some. Anyone have opened? I mean, it will be easy for us for calculation purpose. There is no need to calculate different value. Yeah, tell me.
45, 55.
Can you tell me the same values? I mean, because there is will not be. Okay, let me open it. Sir. I'm using because we'll be. I mean, there will be time saving in terms of doing the calculation part. That's the purpose. Otherwise, we can take some different values also. Okay, so it's a 10, 34, 14, 42. Okay, fine. 10, 34, 34 for S. Okay, I've taken this. Okay, no problem. 10, 34, and 14, 42. 42, 14. Okay, fine. No. Okay, let's move to the, let's try to understand by this part itself. Okay, so by in week 2, what relative frequency tells us? Anyone? How you can calculate the relative frequency?
The frequency of the category out of the
Frequency of
total.
total, right? Now here we are going to understand row relative frequency. So relative frequency is nothing but frequency by total. If we are interested in row relative frequency, then we have to see frequency divided by row total or not. Correct?
Yes,
So
sir.
row total will be 44 and here row total is 56. Yes or no? Correct? Are you getting my point? Okay.
Yes, sir.
So what is this total? This will be 76 and this will be 24 and this will be 100, right? So this is the row total, this is the row, and what is the relative frequency? We know frequency divided by total, right? So here I'm interested in row total, row relative frequency, right? So that means this frequency divided by this row total, I can do, yes or no?
Yes, sir.
So to calculate the row relative frequency, it will be 34 divided by 44, 10 divided by 44, and for this row, for male row, it will be 42 divided by 56, 14 divided by 56, and for the this grand total, it will be 17 by 76 by 100, 24 divided by 100. So far, so good.
Yes.
Any doubt how we are doing this? Yes, no,
No, sir.
No, sir.
no doubt, right? Now, if you
No,
see the percentage, in terms of percentage, what we do, we can simply multiply by a cost. Sorry, multiply by a 100, right? So what is the 22? Okay, I'm just taking the values. 77.2%. So for S, so it's a 77.27%. Okay, then 22.73% for no. Okay, and then it was 75. Sorry, it will be 75%. Okay, and it was 25%. Okay, so this is for female, this for male, and this grand total was 76%, 24%. Now what method says, please listen carefully. If row relative frequency, so this is the row relative frequencies, right? Correct?
yes, sir.
If row relative frequencies are approximately same, right, then there is association or not?
No association.
No
No
association.
association.
Then there is no association between two categorical variable. Why we are saying no association? I will explain you via the graph. Don't worry. And in the reverse order, if row relative frequencies are significantly different, okay, significantly different, okay, then there is association. Okay, why we are saying if this is same, no association, if this is different, association, I will tell you. Because association tells us if the change in one variable affects the change in another variable, that means associate variables are associated. Okay, if I will plot the, that 100% stacked bar chart for that variable. Suppose this is for female, this is for male. Okay, let me plot. Suppose this is the 100%. Okay, and this one is the 100%. Okay, so for female, So 22.73 are saying no. Suppose this is something covering 22.73. For male, it's a 25%. Okay, suppose this is somewhat 25% is there. Okay, and this green region is for yes. Okay, and same for this green region is false. Okay, what association tells you? If the change in one variable tells us the change in another variable, that means association, right? Correct. If you see, I'm going to make the change in this variable gender. So is there significant change in this variable, or is this approximately same?
Approximately same.
It's the same, right? That means I can say these two are variable are not associated. In the reverse order, suppose there is a case, right? If you calculate the row relative frequency and all, okay, and you got the case like this. Okay, suppose this is the first bar, this is the second bar. There is some background noise. Pawan Gupta, can you? Okay, suppose this is the female, this is the male. In the reverse order, suppose you got the case like this. Okay, I mean, you got the row relative frequencies like this, for example. Okay, this is for something binary, some yes, no, something like that. Now, if I will say change in one variable, so there is change in is this approximately same, or is this is change is there, significant change is there,
Significant changes there, sir.
right?
It's a
So
very
that
much
means,
change.
so I will say these two are associated. So that's why that concept is there. If row relative frequency are significantly different, then association is there. If the row relative
Sir, can you
frequency,
please explain once again, like from the graph, how do we figure out if there is any association or not?
okay, there was background noise. Okay, so what is the association tells us? Change in one variable should reflect the change in another variable, right? Only then I will say it's associated, right?
Yes, sir.
So if you see female to male, something like that, so is there significantly change, or it's approximately same?
Same,
If you
sir.
see red
Yes,
color, green color,
approximately same.
both are approximately same, right? I will say it's no association. Okay. Why we are getting this graph when the row relative frequencies are same. Okay.
Okay, sir.
And in the reverse case, if you see, if you are getting the graph like this, so this will get only when your row relative frequencies are different, significantly different. For example, suppose this is the 12%, for example, then this will be 88%. And this is something approximately, suppose this is the 42%, then this will be something 58%, right? So if you see, there are significant difference, right? It's not approximately same. Yes or no? Correct? The same
Yes,
thing
sir,
you can
understood.
do with the column relative frequency with also, but we are just proceeding with the row relative frequency. You can use either one. It's not compulsory to use the both. But okay.
Sir, so
Yeah.
basically you're trying to say is that if we change gender from female to male, in that case, there will not be a significant change in
Change.
ownership
Yes.
structure.
Okay.
Okay.
Yeah.
So what is the
So
difference in requirements for row and column relative
sorry,
frequency?
sorry. Can you?
So what are the different requirements for calculating the row and the column
In
relative?
row relative frequency, what we are doing, we are dividing by the row total, right?
Yes,
By
sir.
the norm, by the name, if you see column relative frequency means you have to divide by the column relative means column
34
that
by
is this
76.
34 you have to divide by 76, not 44. Okay. Similarly, this 10 you have to divide with the 44.
And
Okay.
can we use either of them or will it be specified?
You can use either one. It's not compulsory you to use this. Okay.
Okay.
You can go with the row relative frequency. You can go with the column. It's up to you. Okay.
Okay. Hmm.
Yeah. So we have seen the association between two categorical. Now we'll see the
Sir, what
association
is meant
between.
by proportion, sir? Proportion. What proportion means? Percentage or?
You can go with the percentage. Percentage is little bit easier. You can go in the point also. Like rather than writing
What is
76%.
meant by proportion? Like
Which proportion?
the proportion of some data towards that row or
It's
something
a
like that.
ratio.
It's a ratio we are taking, right? We are calculating the row relative frequency. Okay. So basically in relative frequency, what we are doing, we are dividing the frequency divided by total. Okay. So by in row relative frequency, what we'll do, we'll divide this observation by the row total. So row total is 44. So 34 divided by
That I
44.
understood, sir. Okay. Okay. That I understood.
Got it?
Yes.
Yeah, yeah. So now we'll see association between two numerical variables. How we can see it, association between two numerical variables. So basically by the graph and all, so you can simply plot, to get a quick idea, you can plot a scatter plot. So in scatter plot, what we are doing, there will be one independent variable and dependent variable. Is independent is, suppose we are normally plotting independent on x-axis and dependent on y-axis. And what do you mean by independent and dependent? For example, suppose one variable you can take age and another variable you can take weight. Okay. So which one will be independent, age or weight?
Age.
Sir, age
Right?
would be independent.
Yeah, weight will depend on the age, right? Something like that. So suppose your data set like this, you have two numerical variables, one is age and another is weight. So you can plot the simple scatter plot, and suppose you are getting like this, that means there is linear association between these two, which is in increasing order, right? Okay, means to get a quick idea what kind of association is there in by two numerical variables. Okay, suppose you are getting the graph like this between age and weight, something like this. Okay, that means there is decrease, right? Yes or no? Okay, suppose you are getting the
Yes,
graph
sir.
something like this, means there is no pattern, right?
Some background noise.
This Pawan Gupta, I think I requested you earlier also,
Yeah,
right?
it is new ID.
So if so, it's a request, if you don't have any doubt, right? So please keep mute yourself. Okay. Okay.
Sir, could you
So
repeat? There was a
Sir,
lot of
I have a doubt.
noise.
yeah, I was about to repeat. Let
Okay.
me. Yeah. So actually, we have seen the association between two numerical variables, right? Correct. Now we are moving association between two. Sorry, we have seen the association between two categorical variables. Now we are moving to this to see the association between two numerical variables. So to get a quick idea how much or what kind of association is there in my numerical variables, it's a very good thing to plot a scatter plot. What we are doing, we are just plotting the pair of observations xi, yi. So xi is the nothing but we are taking independent variables on x-axis and dependent on the y-axis. For example, you have variables age and weight. So age will be independent, right? Yes or no? Weight will be dependent, correct? Yes or no? Because weight can depend on age, right? Age, something like that. So suppose you plot the data. This means for this age, let's say this age is 10 years. So weight is this. This is meaning something for this. We are going to plot xi comma yi. Suppose you have plotted and you got the pattern like this. So this means there is increasing pattern in your age and weight. That means what is meaning of increasing pattern? This means your variables age and weight, or you can simply say x and y, are positively related. Yes or no? Means
Yes, sir.
if there is increase in x, that means your y is also increasing. Yes or no?
Yes, sir.
Correct. For example, on the same thing, suppose you are getting the graph like this in the reverse order. That means this is reverse order, right? That means there is negative association, right? Yes or no?
Yes, sir.
Negative association means x is increasing, y is
By
decreasing.
decreasing.
Or else you can say x is decreasing, y is increasing. Something like that. Okay. And suppose you are getting the pattern like this, something. So there is, you can say there
No
is no
association.
particular pattern, right? So basically, scatter plot gives me a quick idea what kind of association is there in between my two numerical variables. Let's move to the calculation part. How we can find, right? I mean, how much association is there, something like. So very first thing is it's called the covariance. Okay. So what covariance tells us? Covariance basically tells me the linear association between two numerical variables. Okay. And there is formula to calculate the covariance. What is that? We can say simply as the population covariance. What is that? So nothing but 1 upon n summation of I is equal to 1 to n xi minus x bar into yi minus y bar. And this is the y
Sir,
bar
can
is
you explain the meaning of covariance?
the same thing I just tell you, right? So basically, covariance tell me the linear association between two numerical variables. Okay, what kind of linear association is there? Whether the positive association is there, whether the negative linear association is there. Okay, or there is no linear association is there. Okay, I will tell you the thing. So this is the formula how we can calculate the population covariance and sample covariance. Don't worry about which one you have to calculate. It will be clearly mentioned whether you have to calculate the population covariance or sample covariance. It will be clearly mentioned. So the formula difference is in the denominator it will be n minus 1 in case of sample, and in case of population it will be n 1 by n. The things are same. Basically this xi for the uh, one variable and yi for the another variable. I mean, are you getting the point, right? How you can calculate this one? Yes or no?
Yes, sir.
Right? Basically, suppose you have two data sets, then it's simply xi, calculate the x bar, then xi minus x bar, then yi, y bar, and subtract, and you can simply multiply the things. Okay. Are you able to calculate these things for any data set?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So I will tell you one more thing, one interesting thing. Basically, for example, suppose instead of this y, I have x. Okay, itself xi minus x bar, then xi minus x bar. So what is this? Anyone can tell me?
Variance.
This is the
Same
population
variable
variance, right?
association.
This is a
Yeah.
very
If the variable is same, that means variance, and if there are two variables, it's a covariance. Okay. One more important information:
Two
variance.
variable, it's same. So the correlation is 1. That's correct.
Uh, correlation is a different. I will come to that point. You can see variance cannot be negative, right? Because it's a square thing. Okay. But covariance, you can see this covariance can be positive, can be negative, right? Or can be zero also.
Yes, sir.
Yes or no?
Yeah.
Yes, sir.
Yes, sir.
Correct. Because multiplication of these two can be positive, can be negative, can be zero also, right? Now, if you will tell, can you tell me, suppose I'm saying covariance between two variables is zero, then what is the interpretation for this? What will be the interpretation for this?
No
The
relationship.
There
neutral
is
state
no
is no
linear
association.
there's
relationship.
no linear relationship, no linear association.
Be careful. You can simply say no linear association is there. I mean, you cannot say no association. No linear association between x and y, because sometimes it happens. Suppose x is something and y is defined as x square, then covariance between x and y can be zero. But in this case, your y and x are not linearly related, but there is some dependency. Yes or no?
Yes, sir.
Okay. So
Yes,
if
sir.
covariance is zero, that means there is no linear association. Okay. Okay. So I will tell
Sir,
you
sir,
the
sir, can
yeah,
you hold it one step above, sir, please?
this one.
Yeah, please hold. Sir, what is this x minus x bar, x minus x bar? I understood it is a variance of x. What is the below one? Oh, you just added it. Okay, sir. That's
Yeah,
fine.
it
So
will be
what
the
is
square.
that written? Could you
It's a
above variance?
population variance.
Okay.
It's a population variance. Yeah, do let me know if at any point you are not getting this. Okay, let me draw one diagram. Hopefully that will give you the idea when covariance will be positive and negative and all. So just give me a minute. Okay. Suppose this is the case. Okay, this is suppose x-axis, this is the y-axis. So for this axis, suppose somewhat I'm assuming x bar is there and suppose y bar is there. Okay, for case and your observations are some distributed like this. Okay, now tell me what will be the value of xi minus x bar, whether it will be positive or negative in this
Negative, sir.
in this
Negative.
part itself. Tell me negative.
Negative.
And yi minus y bar,
Also
Negative.
negative, sir.
this coordinate xi minus x bar,
Positive.
yi minus y bar,
Negative.
this part,
Both
Both are
positive.
positive, sir.
both are positive, right? In this part,
Why?
Negative
This
and
will negative.
xi minus x bar is negative, yi minus y bar is positive.
Positive.
In covariance, what we are doing, let's say 1 by n summation of xi minus x bar into yi minus y bar, right? Means we are interested in product of these two, right? Here is the population covariance formula. So tell me, what will be the product here in this coordinate?
Positive.
Positive, because multiplication of two negative numbers in positive, right? What will be product of these two?
Negative.
Negative.
What about this? Product
Positive.
will be.
Positive.
What about this?
Negative.
Negative.
Now, you got the idea when it will be positive and it will be negative,
Yes, sir.
right?
Yes.
So, next part is something because let me tell you what the
Sorry, sir,
correlation.
could you scroll up for a second?
Activity question.
Activity, see, we'll discuss at the end of the session because very first priority is to revise the concept. Yeah, someone was asking to scroll up. Yeah, please.
Thank you, sir.
Got it? Yeah. So next concept is called correlation. So what's the need of correlation? Basically, correlation is something, it's a unitless measure. And why we are interested in unitless? And basically, it tells us the strength of association. Means strength means whether it's a strong is association is there, strong, I mean negative association is there, something like. Because if you see the covariance between two variables, suppose I'm saying covariance I got 52. Okay, then covariance between two variables I got, let's say 152. Covariance between two variables for something I got minus 70, and covariance another two I got, let's say minus 170. Okay, so by observing this value, can I will I be able to know the whether which one is the strong association or see by observing the value I can say this is the positive association is there, right? Positive linear association, negative is there, negative. But what's the strength? How much? Can I say? I can't differentiate, right? I can't say 150, 52 is the will be strong and minus 170 will be less, right? Yes or no? Because there is no upper limit and no lower limit. In case of covariance, for a data set, you can get the covariance as 520. Yes or no? Are you
Yes.
getting my point?
Yes, sir.
Okay, so basically correlation comes into the picture for this. It's a unitless measure, and range for this is the, I mean, it's basically denoted as R. What is the definition for this? It's nothing but covariance between x comma y divided by standard deviation of x into standard deviation of y. So what is the main thing you have to keep in your mind? If you are using the population covariance formula in the, suppose question is to calculate the correlation, then if you are using the population covariance formula in the numerator, then use the population standard deviation in the denominator as well. Or if you are using sample covariance formula in the numerator, then use the sample standard deviation formula in the denominator as well. Okay, or else you can use the another formula. I mean, this is the simplest one. The final form. What is that? If this is 1 upon n, okay. I mean, don't use. I mean, in the numerator you have used the population covariance, and in the denominator you are using the sample. Sorry, sample standard deviation. So for this, it
So
will
we
be
can use any sample or population.
anyone, but you have to be careful. That's okay. So suppose this is I'm going to use the this one. Okay. So if you see, this 1 by n will get cancelled out this 1 by n, right? Okay. So final form of this will be summation of xi minus, let me write down on the next page. So R will be summation of xi minus x bar into yi minus y bar divided by square root of summation of xi minus x bar square and square root of summation of yi minus y bar square. So this is the final form which you can keep in your mind. Okay. So if you are using sample, then it will be n minus 1, n minus 1, n minus 1. It will get again cancelled out. So this is the final form of this one. So you can use this one. Is this clear?
Yes.
Okay. So there is a limit for this R. So it will lie between -1 and +1. Actually, that is the limit. So if R is close to 1, very close to 1, I mean, so do you want to write me write that range?
Sir, excuse me, sir.
Yeah.
Yes, sir. Please
Above
write the range.
equation, sir.
Sorry? Yeah,
In
yeah.
the above equation, sorry, you will just scroll up, sir.
Yeah, no problem.
That square root under
Mm-hmm.
denominator, that square root of summation of xi minus x bar whole square and this one denominator term is there, na sir. That
Mm-hmm.
square and square root will be cancelled and up and
How you can
can
cancel?
Is summation, right? So it cannot
It's a
cancel.
summation. It's
Oh,
not about only
okay.
whole square. Okay. Different.
Summation. Okay, sir.
Okay. It means simply it means summation of 2 into 4. For I'm just taking square root of summation of 2 square. Okay.
Okay. Plus. Okay.
Okay. So if R is lying between 0.75 to 1, so you will I can say strong and positive linear association is there. It's not important for exam point of view, but yeah, fine. Let me write a little bit quickly. So it's a strong and positive linear association. If your R is from zero point 0.5 before 0.75, then I will say moderate and positive linear association. Okay. And if it's 0.25 and less than 0.5, then I will say weak and positive. Okay. Linear association. And if it's minus 0.25 to 0.25, then I will say absence of linear association. You can't say that is, I mean, those are not associated at all. Absence of linear association or relationship. Okay. Be careful with the linear because covariance correlation tells us the linear association. And if it's minus 0.5 to this one minus 0.25, I will say weak and negative linear relationship. Okay. And if it's minus 0.75 to minus 0.5, then I will say moderate and negative linear association. If it's minus 1 to minus 0.75, then I will say it's a strong and negative linear association. Okay. So you can have it just some rough idea. It's not the exact range, but you will be having some. Okay. Okay. So should we move to the next part? So far, so good, everyone.
Yes, sir.
Yes.
Yes.
So
Sir,
now
when can we say association is positive?
this is the positive, right? Till now, it's a
So I
positive.
mean association between two categories X and Y. When can we say it is positive?
Two what? Two category. Can you repeat?
Association between two categories X and Y.
So when value, if values are positive, if 0.75 to 1, 0.5 to 7, 0.25, it's a positive.
I think he
Like
is asking about two categorical variables.
yeah.
So we can't.
No, I did not get his question. Can you repeat,
So
please?
previously you were saying if X increases and Y decreases,
Uh-huh.
then association will be negative,
Yeah.
or even the contrast happen. Uh, the
Yeah. If
association
okay,
will be negative.
what
Then
they yeah.
when it will be positive?
When both are increasing, right? Both are increasing or both are decreasing.
Then it will be positive.
Yeah, this graph, I think you have not listened carefully this part. If you see, both are decreasing, right? Product of these two are less than 0, then product is greater than 0. That means you will get the positive, correct? If both are positive, then product will be greater than 0. If one is
Okay.
positive, one is negative, product is less than 0, correct? Got it?
Yes, sir.
Okay. Yeah.
So what does these quadrants specify in this graph?
Means when your covariance or correlation will be positive or negative.
Okay.
Got it?
Sir, what is unit of correlation?
There is, it's a unitless correlation is a unitless, because suppose age is the sorry, x is the age, okay, y is the weight, okay, then
Yes.
it will be covariance will be in year into kilogram, okay. Since
Yes.
it's standard deviation, then again it will be year, and standard deviation of y will be kilogram, it will get cancelled out. So correlation is a unitless measure, okay.
Okay.
Sir,
Now,
the categories you mentioned, like from minus 0.25 to 0 and all that
uh-huh.
categories, sir, do they stand valid for point biserial correlation coefficient as well?
No, I will come to the point by serial. So in point by serial, actually, we are just treating if its absolute value is lying between 0.75 to 1, then we'll simply say they are strongly related. Otherwise, it's not strongly related. It's not for point by serial.
So, sir, point biserial is somewhat like a categorical variable, right? You can just say if there is a relationship or not, but you can't say if it's
We can't
strong or
say
weak.
explicitly. We can have some rough idea. I
Okay,
will
sir.
come to the only part is left out. Okay. Now till now we have seen association, okay, between two categorical variable, right? We have seen separately association between two numerical variable. Now there might be an interesting question or in your mind, is there any way I can find association between a categorical and a numerical variable, right? Yes or no?
Yes, yes, sir.
Right? Because we have seen separately association between two categorical variables. We have seen the association between two numerical variables. What if I mean, how I can find the association between a categorical and a numerical variable? So there is one method called point by serial correlation coefficient. Okay, so that method called point by serial, no, correlation coefficient, or we can find the absolute point by serial. The only difference we have to take the mod of that. So how it defined as actually, so it's a RPB means point by serial, nothing but I'm going with the modulus, I mean absolute point by serial, okay. I mean you can take absolute. So it's a y bar naught minus y bar 1 divided by sigma x into square root of p naught into p1. Okay. One clarification let me give you. So this sigma x represent the population standard deviation. Okay. You have to take the population standard deviation. And I think in lecture video, ma'am has taken a small s, right? Okay, so
Yes.
that is the error actually. It should be sigma x. We have to take the population standard deviation. Is that clear? Okay, is that all right, right?
Yes, sir.
So it's a
Yes.
Yes, sir.
correction actually.
So
We have to
do
take
you
the
mean why not take the sample in the denominator here?
sorry, why?
Why not take sample? You specify some reason now that we should not we should take this population standard deviation
Actually, that is a formula. Okay, so actually, it's not about we can't take sample standard deviation itself. I will tell you, we can take sample standard deviation as well. Both are correct. But thing is that for this particular form, in the lecture video, by mistake, it has been mentioned small s. Okay, but it should be sigma x for this particular form. I will tell you when you can use the standard deviation also. So sample standard deviation also, right? So for this particular form, it should be population standard deviation. Okay.
So in the numerators, in the modulus,
Uh,
you have written y naught bar minus y
bar 1.
y bar 1.
Huh.
Okay.
I will tell you what is the meaning of that
Okay.
great term. Okay.
Okay, sir.
So this P naught represents the N naught by N, and P1 represents the N1 by N. I will tell you the meaning of each and everything. Now, someone asked for sample standard deviation. Okay. You know that formula N minus 1 S square, I can write N as a sigma square.
Yes, sir.
Correct. So from here, sigma square will be N minus 1 by N S square. Sorry. Yeah. N minus 1, sigma square, I can write N minus 1 by N S square. Yes or no? What will be sigma? Sigma will be N minus 1 square root of N minus 1 into S. Yes or no?
Yes, sir.
Correct. So what the formula we have? We have RPBH modulus of y bar minus y bar 1. If you want to use the instead of standard deviation, then we have to replace the sigma x by this quantity. Yes or no? So it will be square root of n minus 1 by n into sample standard deviation into P naught into P1. I mean, maybe you have seen this form. Uh, so square root of n naught minus n into Sx. So this will be n naught by n, and this will be n1 by n. Okay. What is the meaning of this terminology? I will tell you within a minute. So maybe you have seen this form or not in the lecture video. Have you seen this one? It will be n naught into n, n1 by n. Okay. So this is square root terms. It will be n by 1 n will get cancelled out. So it will be n1 as well, right? Yes, no. One n will get cancelled out.
Yes,
Are you
sir.
getting my point, right?
Yes, sir.
Yeah. Yes, sir.
So you can use the sample standard deviation, but we have to use this form. Actually, okay, what is my point? In the lecture video, ma'am has used this form, but by mistake, it has written as small ss, which means we are using sample standard deviation, but that is the error. It will be sigma x, that means population standard deviation. Okay, is that clear now? Okay. So if you are using this form, so be careful, you have to use the population standard deviation. If you want to use the sample standard deviation, you can go with this form also. No problem. Okay. Should we move to the agenda? I mean main method, right?
Yes, sir.
Sir, I have
Now,
a doubt.
yeah.
Um, how to find the point by serial correlation coefficient if there are more than two categories? Like, for
See,
example,
okay, let me clarify. Point by serial correlation coefficient defined for a categorical variable and for a numerical variable, and that categorical variable should be something which has two forms. I mean, it should be two categories only. Okay. In foundational course, we are going to deal with only this part. Okay. We are not moving beyond that. Okay.
only
We are,
dichotomous variables.
yeah, only two categories. Okay. Now, so let's say I have two variables. One is gender, and let's say I'm going with this part. We have gender, and let's say thing. Okay. Suppose I have two things. Okay, two variables. First one, let's say gender, and another one is marks. Okay. Suppose this is the female. This is 98. Suppose this is the male. This is the, let's say, 92. Okay. Then male 70, female 68. Okay. Then male, let's say, 56, and then female, let's say, 80. Okay. So tell me, gender is a categorical variable, right? Marks is the numerical variable. Here I'm
Yeah.
interested to calculate the point by serial correlation coefficient. Now, what is that formula RPB? I mean, absolute point by serial, you can say. I mean, see, thing is that you to just be careful. If it's not about absolute point by serial, then see about this y bar minus y bar 1. Okay, let's go with this absolute one. This is sigma x, and this is square root of p naught into p1. What this p naught says, n naught by n, and p1 says n1 by n. Means, so there is, for this gender category, we have only two category, right? Female and male, right? So one variable you can code with 0, and you can code with the 1. Okay. Let's code female as a 0. Okay, or let's say code as female as 1, then male I can code with 0, right? Yes or no? Yes, no, are you
Yes,
getting?
sir.
Now,
Yes, sir.
if you
Fine,
see
sir.
in the formula, we have to calculate the P naught P1. What is P naught? N naught by N. So P naught means N naught by N. So what this N means? Total number of observations. So what is the total number of observations? 6.
Yes, sir.
Yes or no? And what is the N naught means? The observation which is coded by 0.
3.
Everyone is getting right. So it's a 3. I mean, if you see, there are 3 observations which are coded by 0, right? 1, 2, 3. Yes or no? So it will be simply 3 by 6, correct, which is 0.5. If you see P1, which means N1 by N, it's a proportion basically. So N is 6, N1 is again 3, right? So far it's okay for everyone?
Yes, sir.
Okay. Now in the
Can you
formula, if you
repeat one?
see, okay, so P naught means we have to take the proportion which of the observations which are coded as 0. Okay. So if you see, which is N naught by N. So N means total observation. So total observation is 6, right? Out of this 6, how many observations are coded with 0? 3, right? 1, 2, 3, right?
Yes, sir.
Similarly for 1 also, right? 1, 2, 3. So I have calculated P naught P1. So far so good. If you see, we have to
Yes,
calculate the y bar naught. So what is the meaning of y bar naught? Tell me. We have to take, so y bar means we have to take the average of those observations which are coded with 0. That means we have to take the average of 92, 70 and 56. So it will be 92 plus 70 plus 56 divided by how much?
118.
Divided by
Yes, sir.
3. Because we are going to take the average of only these 3. Okay. Let's say whatever the value will be. Okay. Now, we have to calculate the y bar 1 also. What is the y bar 1? It says we have to take the average of the observations which are coded at 1. So 98, right? 68 and 80. Yes or no? So it will be 98 plus 68 plus 80 divided by 3. Is that all right?
Yes, sir.
Right? Now, and what you have to do? So if you see in the formula, what is the RPB? It's if you see y bar minus y bar 1 divided by sigma x into square root of P naught into P1. So you have calculated P naught, you have calculated P1, you have to just substitute the value, you have calculated y bar naught, y bar 1. And what is the sigma x? You have to calculate the population standard deviation. So since population standard deviation is something you can use for numerical variables, right? You can calculate, right? So you have to calculate the sigma x. X means you have to calculate the population standardization for this numerical variable. Whatever value you will get, just substitute the values and you will get the sum value of RPV. Is that all right?
Yes, sir.
Any doubt?
No, sir.
Fine. So basically, thing is that
Sir,
you can use the absolute point by serial if it's mentioned clearly absolute. I mean, just go with the absolute. It's a good one actually. Or else try to find the positive value. Positive means it may happen like y bar is less, okay, and y bar 1 is high. Then the if you are not using the absolute value, then this will be negative, right? Or else you can do vice versa, y bar 1 minus y bar 0. So it's good to go with the absolute value, absolute point by zero. Okay. Anyway, we'll get the positive value.
I did
sir,
not get why you are mentioning it's good to go with absolute value. Like I missed something, sir. Can you repeat?
No. Actually, okay. Basically, in the formula, we have this one, right? Absolute. If I'm asking absolute point by serial, right?
Okay.
So we are taking modulus, I mean absolute value of this thing, right? So
Okay.
you can do both two things. I mean y bar naught minus y bar 1 divided by sigma x into square root of P naught P1, right?
Okay.
So sometimes suppose this can be negative, right?
Yeah.
Okay. Then in
So
that case, what you can do, either you can go with y bar minus y bar. I mean doesn't affect. Okay. Anyway,
okay.
we are interested. So it's good to go with the absolute value. That's all.
Okay, got it, sir. Thank you.
Okay, so you got the idea behind this point by serial, right? Okay.
Yes, sir.
Yes, sir.
Okay.
We should
Yeah,
always
so
take the population, right? Population standard deviation.
yeah, if you are using this particular form, then go with the population standard deviation.
Yeah, and if it is not mentioned in the question, it will always be default, right? Population.
Yeah.
Would they ask? Would they ask? Would they ask like divide by sample?
No. They will not ask divide by sample, divide by population. They will simply ask calculate the point by serial correlation coefficient. Then what you have to do, you can use this form. See what I mean. If you are using this form, right? This particular form, then use the population standard deviation, or else you can replace this thing with the sample standard deviation also. Okay, then you have to use this form. I mean, there is no error. Okay. So actually,
In this scenario, we have two categorical variables that are male and female. In other questions, they ask more than two categorical variables. What can I do, sir?
No, there will be only two categories about point by serial.
Okay, sir.
Okay, it will not be. We are not going for more than two category as of now for this first term of stats course. Okay. So
Sir,
my
when I
main
Googled
concern
the
was, yeah, my one
same
second.
doubt,
One second. My
sir,
main concern. Let me repeat, clarify one thing. My main concern was in lecture video, by mistake, it was mentioned as small s. Okay, but it should be sigma x. Okay, it should be population standard deviation if you are using this particular form. Okay, so this doesn't means you can't use sample standardization. You can use, but it should be in this form. I mean, let me show you. I think maybe some of you have seen that part. I think point by serial correlation coefficient is in the last video. Okay, let me show you. You can use the both one. I mean, but the form will be different. Okay. Okay, let me show that. Just give me a second.
So we would get different answers, right? In both of the formulas.
No. You can't get different. You will get the same.
Okay.
See, here it's a by mistake. It's written small, right? It should be sigma x. That is the one concern. Are you getting?
Okay.
Okay. Now you can use the sample also, but here now this form. I was talking about this form, right? If you see this square root of n1 divided by n minus 1, right? This is the same as this one, right?
Okay. Got it. Yeah.
Got it.
Understood.
Basically, if you are using that form, so it should be sigma x.
Okay.
Now this sigma x I can replace with the sample one by this terminology. Okay, by this quantity. If you'll replace, you will get this form. Okay. So it's good to go with the rather than getting the
I would go with the default one.
population standards.
Yeah.
Okay, fine. But yeah. So I think okay, math session has been started, or
No, sir. This is the last session today, sir.
Yes, sir.
this is
No, sir. This is the last session.
Yes, sir. Started.
No, we have a max session for max 2.
Yes, sir. We have a math session.
fine, no problem. So I think there will be one. Okay, how is the mock? Are you attempting?
Yes, sir.
Okay. So there will be one mock discussion session on upcoming Friday. Okay. So and due date for mock is before till 6 p.m. on the Friday itself. Okay, which is day after tomorrow. So and I think today is due date of week 4 as well, right? If I'm not wrong.
Yes, sir.
Yes, sir.
Okay. So we have covered all the content of week 3 and week 4. We hope you got the idea. Okay.
Yes,
Maybe
sir.
mock session will be taken by some other instructor.
Sir, I have a question.
Yeah.
Yeah, so basically during exam, right, are all four questions, like in all four subject questions gonna be given at once, or do we like do it in 1 hour?
No, it will be given you once, I think.
Okay. And how many questions are there gonna be in exam? Like in statistics, how many questions are gonna be
You
there?
can get approximately 15 to 16 questions. In that, not more than that, because in 15 to 16, from week 1 and 2 there will be most, I mean there will not, I think Pawan Gupta, there is background noise, can you mute it? Yeah, thanks. So in week 1 and week 2 most of the things are theoretically, right? So it will
Yeah.
take some less time. Okay, but okay, one more thing, let me clarify. Don't worry about too much calculation. Okay, there will not be any too much calculation. I mean, there will be calculation which you can do very on an easy way. Okay, you may have I mean, you may have seen some problems which involve too much calculation, practice assignment and graded assignment. Don't worry about that. There will be less calculation. We are just about to check your concept. Okay, so maybe mock session will be taken by the another instructor, because I have to take some another session. Maybe I'm not sure. Okay, so hope you got the point. Okay, you got the idea. Okay, so thanks all, and all the very best for your qualifying exam. Let's meet
Sir,
after
sir,
the,
I
yeah.
have a doubt.
Yes,
Sir,
yes,
I have
yeah.
pasted a doubt in a chat box. Can you explain it right now or later?
Which doubt?
Sir, it's a box plot question form of quiz, which is not graded.
Box plot. Not able to see. It's not box plot. One histogram I can see.
Sir, in the question, it says plot a box plot diagram for the data.
Okay, so I done. Okay, so it's a okay. It's a histogram. It's not a box plot. First of all, so
No,
I
sir.
don't see. I'm not able to see
In the
the.
question, it's given the data in the histogram, and it says plot a box plot diagram for that
Fine,
given data.
fine.
And there
Yeah.
is an option with
Okay, so what
four
are the
box
things
plot
which?
data.
Okay, what are the things which are required to find the box plot?
So minimum, maximum, and Q1, Q2, Q3.
Just find that, and you can simply plot.
Sir, I can't understand that box where it started and where it's ended. And the single line, it's a minimum, maximum. But for the
So
box, it's confusing.
where this question is? Where?
Sir, it's in a mock test 2, not graded.
Okay. So see, first of all, try to find the observations. So 6 is occurring 7 times, right?
Yes, sir.
Right?
Mm-hmm.
7 is occurring 12 times.
Yes.
8 is occurring 12 times.
Yes.
9 is occurring 7 times.
7 times. Yes.
10 is occurring 2 times. Now you will be having the observations.
Yes, sir.
Now you can calculate the Q1.
Q1. Yes, sir.
See, the very first thing you can see, what is the minimum observations? 6, right?
6. Yes.
Correct. The minimum should be at 6, first of all. You can see one for one box plot, for two, in the two options minimum is starting from 5. That is absolutely wrong, right?
Yes,
Okay.
sir.
The same approach you can see. You have observations, calculate the things, right? Got it?
Sir, I know the minimum maximum value where it can start and where it stop, but that box it is given that confused me.
So I think observations are clearly there. What's the problem? I'm not getting. See, if you see here 6 is there, maximum is 10 is there. Here first quartile is 7, second is 8. That is the meaning.
Then, sir, where we plot the 9?
What about 9? See, first of all, let me clarify. If you are going to plot a box plot, right? So box
Yes, sir.
plot means this should be the minimum, right? And this should be the
Okay.
maximum. This is something Q1. This is something Q3, right?
Okay.
That's all. And in between will be Q2. Okay, in between will be Q2. But here Q2 is not mentioned. Q2 means median. So what they have done in this particular part, they have clearly colored with blue color. So that means you have to see what is the minimum, what is the maximum, what is the Q1, what is the Q3. That's all. Fine.
Okay, so it doesn't matter how much data is given. we just get minimum, maximum, Q1, Q2, Q3, and plot the box.
Yeah, so simply first
Okay.
join the first find the all the observations, right? And then calculate. Okay, fine. Oh,
Okay.
okay, okay then.
Sir, are
Let's start.
independent variables and explanatory variables the same?
Sorry, are
Not an active.
your voice is breaking a lot. Can you write on the chat box?
Hello, am I clear?
No, there is background noise. No, can you write on the chat box? Okay, so others can the phone is going to write on the chat box. I will see this and then okay. All the best, all the very best to all of you for your qualifying exam.
Hello.
Yeah, yes.
Sir, are independent variables and explanatory variables the same? Like,
Yes.
independent and response variables are the same.
Yeah. Both are the same. Just different nomenclature.
Okay.
Okay. Okay.
And so, how, can we derive this outliers formula? I don't understand how it works.
Actually, we are okay. So, Pawan, we are not going to in the derivation part. Okay, that's not important your quiz point of view. We are just saying the basically this is the very first foundational level course. Okay, so we are just revising the concept. Okay, we are not going to the derivation part. Derivation and all the formula behind the algorithm, behind the formula and all, we can discuss it later on. Okay.
Okay.
Yeah. Okay. Then thanks all. Bye. All the best for your
Yes,
exam.
sir. Thanks.
Yeah, thank you.
Sir, what is the weightage of question in qualifier exam?
So syllabus will be from week 1 to week 4, okay? Some portion from week 1 and 2 and some portion from week 3 and 4. So it will cover week 1 to week 4.
Yes, sir.
Sir, how much time will be given for each course?
So for each course, it will be 1 hour.
Sir, uh, which week to weightage maximum question?
I'm not sure, but you can approximate, say from week 3 and 4.
Okay.
Sir, we have to submit each paper for each subject, or we have to give altogether 4 hours.
Sorry. Okay, so this okay. First of all, this is something you can clear with the support team. Okay, they will help you. Okay, so they will help you. Okay, so it's I think that you will be given some 4 hours because you will be having 4 subjects. Okay, so you have to do the all 4 subjects within that 4 hours. Rest, if you have doubt, then you can mail or write to support team. They will help you.
Hello, sir.
Yeah.
Sir, what is curvature?
What is
Curvature.
curvature? Okay, tell me. Okay, what is that association part? Can you explain?
Association between two numerical variable. Describing association.
Hmm.
Sir,
Actually,
yeah,
see, it's not about see in basically in correlation and all. We are saying just linear association, right? Curvature.
yes,
There might be some curve and all, right? But we are not
yes.
in. I mean, for this course, we are just interested to. We are learning only curve. I mean that linear association. We are not moving that I mean whether they have some polynomial relationship. Any curve is there. Okay.
Okay, sir, right.
Okay then. Thanks, Ola. Okay. Yes.
Thank you.
Thank you, sir.